So this represents me gazing into the future of block explorers, and I'm here today to talk to you about where I see that going. Now we'll start with the future of Bitcoin SV. So we all know that the roadmap contains things like zero-conf transactions, fast transaction propagation, and minor configurable fee policies. And most of these are aimed at handling bigger blocks as they come in. So what does this mean? I mean, bigger blocks obviously need more processing power and more storage. So this means that a connected node, and by node I mean a listening node, a connected node will become more expensive to run. So does this lead to centralization? I don't think that's a yes-no answer. There may be less home users connected to the network, but I think there'll still be a minimum amount of different entities running nodes. So there'll be a balance. So now, this is block explorers today. We all know them. We all use them. They're fairly mundane things. They've been around since 2010 and haven't evolved that much. In fact, not really at all until the fork last November. They present a standard visualization of the blockchain for humans. They allow searching of op return data, which is a fairly recent addition. They show which miner mined which block, something we guess from the address or the Coinbase transaction, and address balance. And we also provide an API for RPC calls. So at the moment, it costs to store data on chain, but it's free to read. And in the future, as we were just talking about, we could see as the miners become more competitive and want to mine these big blocks, and also as they can set their fee policies to be more, maybe for data they charge one amount and for normal spendable transactions they charge another amount, then we'll see it becomes cheaper to store on chain, but it may cost a small amount to read. So as I said, our miners are running prune nodes, which means they remove all non-spendable outputs, so they don't have the data. But in the future, that may change. So this shows two scenarios in the world of block explorers in BSV today. Many will fail. This is non-dedicated explorers that also mine other chains. They may not be interested in the investment necessary to run this full node, and once the scaling starts, so they may drop out. And many will join as other people see the value of, well, they buy into the Bitcoin Satoshi vision, and they see the value of data on chain, and they will then say, yes, I want to be part of that, and they'll sort of flock to join. So it's going to be a very dynamic space, I think. It's going to be very exciting there, lots of competition. And these two are not contradictory. I mean, they'll both happen. So data on chain. So as blocks contain more data, it's going to become more difficult to extract information from that data. And especially as the data becomes structured in more complicated ways. So, for example, metanet trees. This is something we're going to have to work with and extract, which we didn't have a few months ago. So, as I say here, getting simple data is trivial, even for large amounts. But to really get value out of this, the really good information out of this, we need some kind of a pipeline. So I was wondering what other areas face this sort of problem, where you need to process a lot of data before releasing it to the public. So I looked elsewhere in the universe for inspiration into space. So studying stars, for example, involves lots of data, temperature, chemical makeup, and brightness. And if you want to study all the stars in the universe, or even in the galaxy we live in, the Milky Way, then you're going to need quite a scalable way of doing that. So I'm looking back into the 1980s here. Hipparchus was launched, could study 100,000 stars. So I think it produced 30 gigabytes of data in 3.5 years. But the Milky Way contains billions of stars, and that's not scalable. So we needed some innovation. So Gaia, this is a European Space Agency telescope which studied 2 billion stars. and collected 200 terabytes of data in 5 years, which is, yeah, much better. So how did the Gaia people process that data? So this is a Gaia contained 3 instruments, and the data came down to Madrid via satellite link, and there it was split up, depending on which instrument it was, and sent to 3 different processing centers in Europe. So below low spectra, data was sent to Cambridge, which is my hometown. These processing centers process the data, and sometimes they rely on other people, and they get anomaly reports about data which is maybe a bit not as it should be. And then when they've done their processing, they send the information back to Madrid, where it's then distributed every month, or every couple of months, to the public. So in WhatsOnChain, we do a similar sort of thing. When the block comes in, we go through all the outputs for the data, we pass them, we split them up into different protocols, and we send them to different protocol parsers. So at the moment, WhatsOnChain is running all these protocol parsers, but the infrastructure and the framework is there to allow other external processor partners to process this information, and we could pay them once when they process the information, or we could pay them a microtransaction each time their information is used or called by a user. Obviously, we'd have to pass this price on to the user somehow. Yeah, the protocol parsers return the information to WhatsOnChain, where it allows us to analyze it further, get more information out of it, and maybe for metanet edge weighting or efficient searching. So this raises a question. If we're using external processing, how do we trust these processors? How do we know that they're telling us the truth? And in fact, how do companies or anyone trust WhatsOnChain itself? Why should anyone trust an explorer to give them an honest view of what's on chain? So we have a solution for this for miners called Miner ID, and Steve mentioned it earlier on. It's a miner ID is basically a public key part of the ECDSA key pair, which a miner can then put in a Coinbase document. It's basically just JSON. They'll put that Coinbase document in an op return and mine it into the Coinbase. And it's very simple from that to work out the reputation of a miner. For example, we will know that miner A mined 10% of the last 100 blocks or something. The miner signs this, so we know that whoever owns the private key mined these blocks. So for non-mining entities, how could we do this? I mean, the example I came up with was a miner could issue a certificate, like an X509 certificate. So, I mean, we could get certificates from multiple miners, and depending on their reputation, the miner's reputation, the certificate would be worth more. And so if 5 different miners issue certificates to WhatsOnChain, that would mean that miners who are an integral part of the Bitcoin SV world have trusted WhatsOnChain or whoever to basically to say that, yeah, these guys are honest. That's one way of looking at it. And auditing is another option. So we could randomly audit our outputs or distribute that auditing to other people and ask them to audit us. And these auditors could be paid in microtransactions as well, some kind of fee to audit it. And we could do that every month or something, or every 6 months, I don't know. And that would also show that we're returning an honest view of what's on chain. And of course, there's also the traditional method, which is basically how we trust Amazon. We know that Amazon are not going to steal our money because they've been around for a long time and they have a good reputation. So I'd hope WhatsOnChain could also rely on that a bit. So the future's not just driven by what we imagine, it's also driven by reactions to things that happen. And we run WhatsOnChain on STN, and we get quite a lot of results from that. I mean, we know it works with big blocks now, but there's also load testing on mainnet, which I don't know, it happens occasionally, and that's a different sort of testing because we get users hitting us as well. And yeah, we've had a few problems like everyone. And the results, some of the results have made us change how we do things. We changed the database from Mongo to Postgres, for example, to take advantage of the relational nature of Postgres, which echoes pretty well the relational nature of the blockchain. And we also decoupled the application from the node as far as possible, because the node was getting very busy working and doing what it does, and our application was trying to ask it for things. Even though we were caching, it was still trying to ask it for different piece of information, and it wasn't responding. And so we thought a stale view is better than no view at all. So it's better to show a slightly older version of the chain than just to crash completely. So that's something we've also built in. Now, this is another topic that's come up, I think, in a few other talks. We need to talk to multiple nodes in different geographical locations to get an honest view of the network. So when the question is asked, is a transaction in the chain, we can't simply say yes or no. It's not a binary answer anymore. We can say, yes, it's in all the tips. No, it's not in any of the tips, or maybe it's in some of the tips. We could give that as a the percentage that it's going to be mined. Also, another thing to think of is zero-conf means that the transactions in the mempool become first-class citizens. It's as important to parse them and index them as it is transactions that are mined into a block, which is something we don't do at the moment. At the moment, we can see the transactions, but we can't search in the data for these outputs. So that's something that's going to have to change as well. So, so far, WhatsOnChain, we're just 3 people. We don't have funding. We've never had any external funding at all. We do have an infrastructure partner who's Satoshi.io. And this is an example of one of the machines he allows us to run some services on. It's quite a big machine. It was specifically, the processors were specifically chosen to have performance for single and multi-threaded applications. So it seems it will, I think, be OK for quite a while. As we start scaling, obviously, we're going to have to look at this and maybe get a few more. Monetization. So obviously, we want to make some money from this because we're paying for things and we need to get something back. So already we have a Bitcoin node API which allows users, it's limited to 3 calls per second, and after that we would have some kind of a pay barrier. At the moment it's not there, but I think in the future we may do that. Retrieving data is a thing we spoke about with the miners. So this is obviously something we'll be looking at because we have the full index blockchain. We'll also want to be part of that service. Customization API. OK, so we get a lot of requests, and lots of them are about presenting a customized view of the blockchain or of transactions or of financial reports and services. So we can offer that. That's something else we could make money from, and financial reports and other services. And of course, there's lots of other things we've thought of which we don't really want to present here at the moment because, it's sort of still in development. And that's all I have to say, really. The team is here. All the guys are in the room today, Simon and Mohammed. Thanking nChain and the workshop and Satoshi.io. And of course, Doctors Halaby and Busso, the astrophysicists.
Come on. Bring them on up.
OK.
Come and meet the rest of the WhatsOnChain team.
Thanks.
Come on. This is Simon and Mo. Simon's also an nChain, and Mo is not. While I've got these guys here, actually, I should take a moment to acknowledge that they are doing a few of the things that I often get the credit for. So the Miner ID project and the Merchant API project, these are the guys who are building it. Wei and Owen, who you saw before on the panel, and Dr. Alex Mackay, who you'll be seeing a bit later, have also contributed a lot to the research and the research of the block propagation techniques that we've been working on as well. So thanks, guys, for your work on those things and your work on WhatsOnChain and whatever else it is that you do in your mysterious job.